Okay, so I'm Patrick, and I'll try to talk to you today about Go. Just a quick note, there will be a lot of new things that you might not bother remembering or whatever, and a lot of new syntax. So just interrupt me if you want to ask a question or something. I'll gladly answer that. So, Go. Have how many of you have ever heard about the project? Do you know it? Have anyone used it? Actually wrote code with it? Okay, good, good. So you can correct me, and I hope everybody don't notice my mistakes here. So to quickly recap, that's one mascot that the original inventors of the language came up with. They decided that Go would be the name, a gopher, and this gopher will be the icon for them. So to quickly recap, Go was a project started at Google in late 2007 by Robert Griesmer, Rob Pike, and Ken Thompson, with many others coming to the project later on. It was first announced outside Google on November 10th, 2009 on googleblock.com, and they had their very first version 1.0 and released in March 2012. It was originally whole in C, with small bits and pieces in assembler, but then in August 2015 they decided to rewrite it whole in Go, so it's like self-hosted as of now for several years. They average around 2 releases per year, average. So you might ask, why yet another language? There is like, I don't know, 100,000, tens of thousands of languages around the world now. So the key designers of the language decided that they cannot bear anymore of the complexity of languages produced and used today. So the original goals were simplicity, productivity, readability. They wanted it to be a compiled statically typed language. They wanted it to be a scalable to large system, just as Java or C++. They wanted it to be quick, both at runtime and at compilation, and to support networking and multiprocessing, since it's the way to go nowadays. In terms of speed, I just wanted to quickly mention, I measured it 2 days ago. So on my machine, just a regular laptop, the whole tool chain with compilers, tools, and I'll show you how many of them they have built into the tool chain. It arounds 1,200,000 lines of code with standard library, network library, whatever they have it, linting tools, race detectors, you name it. It compiled around 20 seconds, every single file in there. So I think they achieved their goal quite well as of now. The project is a bit mature now, so it's like 10 years from the initial days. The purpose, as one of the core maintainers, as now Brad Fitzpatrick called it, it's really to get shit done language. It's whatever you want to do, you can get it really quickly done in Go. So I'll try to go quickly through all of those, and then show the biggest features, as they call it, of Go. So in terms of simplicity, you have the tool chain that you get out of the box, and the binaries are for every single operating system out there, I believe. Every single major one. You have a lot of tools like these are the built-in commands that you get: the build, the compile command, the doc, which is the built-in documentation tool, the testing tool, which is also built in, and so on. We've got also the Go vet tool, which is I'll go about it later on. There are also tools which are also built in. One of the most professional ones in here, I would say, is Cover, which is built-in tool to generate coverage reports. You don't have to install anything else. You've got beautiful reports, HTML, whatever you want, whatever form you want it, you can get it. pprof, which is a built-in profiling tool, which you can also connect it with other tools for visualization and stuff like that. And the vet tool, I've mentioned a second ago, which is the tool that starts where the compiler ends. So its purpose is to examine your source code and report suspicious construct like printfs without arguments, or printf calls whose arguments do not align with the format string and stuff like that. So how do you invoke it? It's that simple. If you want to build it, go build. If you want to run it, go run. Get dependencies. You just specify the path of your dependency. So if you want to do it with the GitHub projects, you just go github.com/ and whatever you want it, and it will download to your computer and you can use it. Tests. You just use one command if you want to write. If you want to run all the tests in your project, there's one command to it, and you get the report that you wanted. Extending on the point of the toolchain. So I'll be showing small snippets of code that the syntax for some of you that haven't used it might be a little bit off. It was for me at the very beginning, but you can get really used to it, and it feels quite fun after some time. So extending the point on the toolchain, for instance, Go doesn't allow you to write code that with unused variables. So if you want to run this snippet of code, it will simply print that you cannot. It doesn't compile since you haven't used the y variable there. If we want to edit it and then just remove this line, then it should at least normally run and then print whatever was there. So that's a nice tool that you get out of the box. You can get it obviously with C++ as well, but you have to add some flags, and then it's not the default behavior, right? What more? You get one of the tools that was on the list. I probably haven't mentioned it. Is GoFont, which is Go formatting tool. It's also built in. So Go has a feature that many dispute, and there are also argues about it, but it doesn't accept the code that doesn't adhere to one single truthful coding style. So for instance, here in this snippet, I've got the brace in the wrong place. So if I want to run this one, it will complain that there is a syntax error and unexpected new line before the brace. If I remove it, it will compile without any problems. And the nice thing about it is that everybody complains about it, but it's also it also adds a lot more features, so that it's easier to write. You never worry about minor formatting concern. It's easier to read. You can read if you read one single piece of Go code. You can read code all around the world, and it will look all the same. It's easier to maintain. Only mechanical changes to the source code don't cause unrelated changes in the file's formatting. So this shows only the real changes. There's not an issue in that. And it's uncontroversial. You never ever will have any single more debate about spacing or brace position ever again. In terms of keywords, it just those 25, if I count it correctly, keywords, and that's it. You don't need anything else. That's the whole language keyword specification. Another controversial thing, which makes it simple, I think, is that in Go you write the code in packages. As you can see, I wrote a simple package zoo, which has two types, lion and a tiger. And the lion, which is written starting with a small letter, cannot be used outside of the package, while the tiger, being started with a capital letter, can be used somewhere else. So I've written the package main, which tries to use both of the types, but it cannot use the lion since it was unexported. It's also one of the things that instead of making public, protected, and whatever, then it just distinguishes the small and capital letters. Okay, enough with the simplicity thing. There's more about it, but we don't have that much time to talk about it. So what can it do, actually? So I'll try to go through 4 mostly points that I think are the most important parts of Go's runtime. And that's the interface system, goroutines, channels, and statically linked binaries. So as for the interface system, the idea behind interfaces in Go is to make data structures and interfaces orthogonal. So you have your data structures are one thing, and your methods to those data structures are a second thing. We've got 2 points about this. There's type embedding, which is a form of composition or non-virtual inheritance, and then interface, as I've mentioned before, it's a form of virtual inheritance. So for the embedding, you can embed whatever type you want inside another. So I've got a type job here, which in which I've embedded the logger type, and since I didn't give it a name, I can easily use loggers methods inside the job. So you can see I can just log whatever from the job.log, and whatever I want there. This is the alternative to non-virtual inheritance, as I mentioned. The more important thing is the interface bit. So here there is another really simple snippet that gets you the idea that about the interfaces. So we've got the runner interface. So to declare an interface in Go, it's just you type, then the name, and then the interface, and then the methods that are comprised in this interface. So I defined the runner interface with method run that returns an int, which is the distance of the units that type that fulfills that interface run. And then I've got a function that accepts this runner and prints how many units did it run. So I've decided I've declared the human type, and then I use it in the main function in the very bottom. And you might think the type human struct. There is one. So so as I've mentioned, the data structures, the human empty structure here, it doesn't matter. I didn't put any fields intentionally, and the run method. This is what it's called, the receiver in Golang, and this is the idea is the same as you would declare methods for a type in C++ or other languages. So it's a method, or it's a method declared on the type. So you use it as the idea behind it is that by this declaration, by this function here, human type fulfills this interface, so that you can use it in place where the function requires a runner. So that it requires a runner, which is only a type that would have a run method. And we use it in here.
Okay, so we can have virtually, like, for example, interface like runner2 that also has a run method, and they're like identical, right? And it's not a problem.
But if do you define it as a separate type, or?
I mean, type runner2 interface, which also has run, and then human confirms to both, right?
Yeah. So the idea behind it, which I was heading to, is that interfaces, as you may know it from other languages like C++, Java, or whatever, is that they are not declared explicitly. Types fulfill interfaces implicitly. So you don't. There is no keyword about this and that fulfills that interface. That's the bit that it's quite odd at the beginning, but you can really get used to it. And I will show some samples that it shows that it's really handy later on. All right, so that's this. And then we've got a lot of, like, in standard library, you have a lot of interfaces that are very small ones. You could have used a wider interface and then require a way more from the type that you accept. But this would kill the purpose of the interface. So, for example, from the very heart of the Golang standard library, you've got on the top part package.io, which has reader and writer interface. And whenever those two are used in the standard library, you can declare your type, read write method for them, and then you can use it in standard algorithms that are in the library. As I've shown you with the embedding the types, this is the same for the interfaces. So you've got on the bottom half a read-writer interface. You embed a reader and a writer in it, and then this one requires both of the methods. So to give you an example, let's say that we declare a string. We've got a string some IO reader from stream to be read. And then we create a reader out of it here so that it has a read method. So as I've shown you in the top half, there's an algorithm io.copy, which gets a reader and a writer and copies from the reader. It reads from the reader and writes to the writer. And just with this small snippet with the getting the reader here, we can put it inside the io.copy, and then it will copy from the reader, from the string out to the standard output. But this gets even cooler if you get to know that you can apply methods to plain data types. So we can declare, for instance, a temperature type, which is simply a float. It basically means this declaration here, it's not a type def, it declares a new type, which you can append new methods on. So if we add a function, if we add a method to the temperature, which will fulfill, that's another simple interface from the standard library that returns a string. And whatever you want, for instance, to print a type, if you fulfill that string, then it will print in this particular manner. So I decided that I can just print the temperature with 2 decimal places, and then I just pass this type to the formatting printing function, and then it uses the method that I decided that I fulfilled the interface, the stringer interface. But this gets even more crazy when you get to know that you can add functions to functions. So this is an example from the HTTP package. So the idea here is that you get a HTTP handler interface. This is the interface that you have to fulfill if you want to write a handler for HTTP server. And then this is kind of like an adapter thing, which you would pass a regular function, but you need to have a serve HTTP function here. So you add to this type, which is a function, you can still add another function that would adapt it to the interface of a single call in HTTP server. And this is basically all that interfaces, which we'll touch later on at least still. And I'll go on to goroutines and the multi-concurrency bit as of now, starting with goroutines. And goroutines are the kind of like lightweight user space threads in Golang. They start, if you create a goroutine, and if you think about it in comparison to a normal OS thread in any other language, it bears very minimum overhead. So as of now, the Golang team decided, after several years of debates, that the 2 kilobytes of stack space is kind of like a average stack space that you would require, that your code would require, and then there's a lot of complex logic behind it that you don't have to see, but it grows and shrinks automatically, handled by the runtime. It's very cheap in context switching manner. So it basically, instead of a whole context switch when you use OS threads, this only switches a single instruction pointer and several registers, and that's it. And since Go 1.3, they have contiguous stacks, so it's way more cache friendly. Simple illustration of how it works. We've got three notions in goroutines behind the scenes. So the idea is that the the triangle would be your typical OS thread. You call it POSIX thread or whatever, which handles the execution of the code. The P would be the context. You can call it. They call it the processor, and this is the what actually executes the code, and holds the whole context of it. And G, which is the goroutine that I've mentioned before. So having the model, we have the M's, which are the OS threads, the P, which is the actual bit, the processor that handles the context of it, and then the queue of goroutines, which are waiting to be executed. How it works by default on all single architectures and operating systems is that they spin actually the number of cores. The number of P's is the number of cores on your machine, so that it is getting the M to N corresponding between the cores and the goroutines. But you'd say that it would be enough to just put the why we have context at all, why we have this P. Couldn't we just use the M and then just put the stuff on the OS thread? Well, the problem would be if you get any kind of blocking I/O or syscalls, then you would have to context switch the whole thing. And in their model, they use they put the go routine, so the code that is blocking at the very at the moment that it starts blocking, they put it on a separate thread, and then spin a new one, and then put it in the context, the whole queue, so that it can keep on executing until the blocking call gets back to the OS. And the beauty behind it, the user-facing beauty, I would say, is in its syntax. If you were to spin a new Go routine, you just prepend the Go to the function call, and that's it. It's starting executing in a new Go routine. So the small snippet here is that with this loop, I spin a Go routine which will just print the number and go until the main function exits. I put the sleeps here, but I will talk about them later on. That this is just for illustration purposes. So as you can see here, there are two Go routines here. The one is which is printing, and the other one which is sleeping, and then the other one, the main one, exits, and then we have get out of the main function. No, this is what happens here actually. It does exit first. So if you can see here, there is no condition for this loop. So this is like an endless loop. So what I wanted to go for now is that there is no kind of like terminate on not joining or not detaching threads, as you know from C++. If main exits, then all Go routines are brought down. Yeah, I mean this is managed by the runtime and the garbage collector. Yeah, yeah. There is one which is optionally on and off. Yeah. Yeah, it does. It is. We will go on. Yeah, we'll go on with the later on. We'll discuss about with the results. So, continuing this, if you want to append an anonymous function inside a Go routine, you just add Go to the function declaration, and that's it. And this is basically the same thing that you've seen on the previous slide. And then this is the example that I wanted to show you about with the built-in synchronization mechanism. So this is the very simple we call a sync.wait group, which basically you get the amount of done marks that you require, and then wait for all of them to complete by the invocation of a done function. This is pretty similar to the previous one that I spinned off. This simply gets the random timeout as of here. So I spin 10 go routines in here, and I get them finishing off with the random timeout between 0 and 10 seconds. And that's basically it. I waited for 10 of them here, and then the main executed. Then we get to the last, but I would say most important part about it, which is channels. And channels are the synchronization built in Go language, not in the library, but in the language itself. They propagate the notion of communicate, so that we don't communicate by sharing memory and then locking, but to share memory by communicating. So as mentioned before, Go standard library is quite comprehensive. It includes, like, for instance, this sync wait group, mutexes logs, or whatever. But idiomatic Go code would be written with channels. And if you have like explicit logs or mutexes, that it's probably a cold smell somewhere in your projects. So the syntax with the channels is simply by attaching an arrow to a channel that, if I get my cursor back. So it's basically you allocate a channel, which is a chan of your type. It's a type construct, so you can put whatever type you desire here, and then you can pass it, for instance, to a function, and then you either send or receive on it. The syntax is that if you want to receive on it, you put an arrow in here. If you want to write to it, you put an arrow in the other end, and then put data in. So this example is basically spinning a new goroutine and then sending data, and this worker is simply sleeping for a second just to show that we get data in. So this is like this is a code running in two goroutines, and then one is reading and one is writing. And what is the most important bit is that the reads and writes are thread safe. So the whole idea is behind it, so you can pass your channels whatever, and then wait on it or shove data in it. There is also buffered channels, but which you can allocate a specific amount of space for them. So let's say that I want to have a buffer for 3 ML elements, but I will not cover those here. As yeah, sure. It's quite similar, yeah.
So this channel gathers only one variable of the type, right? As for now. So the main waits until it's consumed, or the main.
No, the whole idea is that it doesn't contain it. It's like a pipe in Unix.
Yeah, I understand. But the point is that does main go and just puts hello world from channel, and then the thread, the go routine reads hello, sleeps, reads world, or is it puts hello, waits for it to read, then puts
Yeah, the second notion. So it basically for a channel read write for unbuffered, for this particular example to run, is that you get you have to have a reader and a writer at both ends, then the code executes. So
it's actually like single threaded in a way that just one of them executes at a time.
no, there has to be a producer and consumer. Yeah. So this is the kind of like a point of synchronization. So there we go. Yeah. Yeah, so I've mentioned you can have a buffered channel. So buffered channel. So you can add to this if you have this main declaration and then make chan string. You just add an int, and then you will have that many items to be put of that type, and it will be buffered so that the producer can put that many items in it, and then just go on with his life, and then the reader can read it later. And you can make channels as well that are read-only or write-only. So I created a channel, the very same example, but I take a channel that is read-only in the method. So if I change this channel here, if I change this invocation so that I put something in the channel, it will not allow me to compile this. And the important part about channels is that they can be used in a select statement, which is a switch case equivalent for concurrency. And this bit here in bold, this one is as you can observe, I've put the channel as before, and then I put it in the function, and then I pass it to the function. Then I sleep, and here the select case statement is either waiting on my channel to read from it, or on a timeout channel, and basically goes like this. I've got an infinite for loop, and then I wait either for my channel or I time out, and then again and again and like that. You can imagine that with a real data source. So here I would have some timeouts. I would get data, and then again some timeouts. So this is a very good example where you can use it, for instance, in RSS feeder or whatever, or market data feed, whatever you want. What's also cool about this is that you get a deadlock detector built in the language itself. So I've created here two you've got the main goroutine and the one with the f function, and I read on both of them. So there's a deadlock. I'm reading on at both points, but I'm not writing anywhere. So the Go runtime will tell me about it, so that every single goroutine is asleep, and there's a deadlock and where it is.
Okay, but if not all of them are asleep, if you had like another goroutine that would just loop infinitely,
There'll be only one blocked, right? You can use.
like if you span in main like another function or another like goroutine that just loops infinitely, for example, would it also report a deadlock or not?
If I only had one and then I continued with my life.
Three of them.
Yeah.
Right?
Yeah.
The main and as deadlocks, and another function that you run through like another goroutine. It just does stuff.
I mean, this one detects if all of your execution paths are like deadlocked, so that you cannot advance, right?
So, okay. That's like the simplest. I mean, that's not a big surprise that if your app freezes, then it's frozen, right? But the worst kinds of deadlocks you get is when you have, let's say, a thread pool or something like that, and two of the threads freeze and others work and do stuff, and you don't see that there's a deadlock, but your stuff gets done slower because, for example, you have two dead threads and some of it is missing in the end. But that's harder. So it doesn't detect such cases.
I mean, this is just that it doesn't get data that it needs, right? They are just spun. Right? Well, like this is kind of like getting closer to real life, but you can get the idea. But this is the very nice example by Samir Aydmani from a Go team, and this is a simple ping pong simulation, so that you would get the player type, which you name it with a string, and then you get the channel of type ball, which just contains number of hits that it hit, and that's all. And then you create a table channel which contains only one ball, but there are two players, and they will be continuously fighting for it, but it will be fighting over the channel. So there will be one that. So in here we will have. We create a new ball, pass it, the table. The players had the reference to the table, which is a channel of balls, right? Just one single ball, and they will get it here, and one of them will get it, will receive it here on the table, increment the hits, print something, sleep, and then pass it back to the table for the other player. And if we take a look at it, it's basically a ping pong with the hits. Okay, so I wanted to go very quickly through through the features that you get out of the box as well. So for instance, there is the cross compilation thing, which you get out of the box. You just prepend Go OS and Go Arch to the build command, and it builds without any headaches. So, for instance, lately I had an issue with my Linux ARM router, which I wanted to put some server on it, so that I accept connections from my network. So everything that I needed to do is just to compile it with those two flags, and it was on. So to show you how it works, so I've got a very simple project here. It's, I don't know, maybe 400 lines of code, and if I just type, and I show you the code, which I'm actually doing. I don't know if you can see the font or not really. Can you see it? Not really. Let me quickly work this out. Any better? Okay, so if I just I've exported the variables Go OS and Go Arch, so it should be. If I put it on the right hand side, and then I've got it building for Linux, and then I've got it building for ARM64. And what I can do is I can build it just here it's just the original binary from the built from Go toolchain built from binary, and what you can see is quite not that fast as I mentioned, but what it did now, it rebuilt whole toolchain compiler and standard library for the ARM64, and it then built my my project. So my project was just this part, which took, I don't know, maybe we haven't noticed it, but this whole other part was building the toolchain and whatever it was there. I can build it with a flag so that it caches it and then puts it on disk, but it was just for illustration how it works. So yeah, you can cross compile without any headaches, whatever you want, if it's ARM, ARM64, Windows, whatever. The same thing goes, you can use build constraints, which are simple annotations on the top of the file. So you just add a comment at the top of the file, and the file will only build for Linux. It will only be on Mac OS and not build on FreeBSD, ARM, whatever you want it. Or you can use the file suffixes. One more thing is that what might bother a lot of you is that the runtime actually takes care of deciding whether something goes on stack on heap, and it throws a lot of people off. So that there is this thing called escape analysis, and it watches watches the code that you compile. It's done at compile time, and as you can see here, what I've done here, the ultimate thing that would be wrong in any other language or in C++, that I declared a variable on stack here, x, and then I assigned the global pointer to it, and then obviously if I would use it, it would go, blew away. But by adding several flags to the run bit, which also compiles the thing, you can see that the x variable goes to heap, which is automatically done there. The same thing goes the other way around. So if you go the unallocated with new, a type that has just a simple int, then you can see that it doesn't escape, it just stays on stack, because there is no need for that as well. There are some other bits which I go through quickly because we're running out of time. There's the thing that you can call C code from Go without any problems. You can go and call Go from C, which is slightly more complicated, but still you can do it. And then I would like to go in a very controversial topic. It's to compare it with C++, and then maybe cut the whatever. But you would say, like, I suggest that we go with the HTTP server example, which is in C++, you can do it, big companies do it, it will be fast, performant, complicated. But why would I reinvent the wheel? But like people do it, and I mean, big companies do it. Facebook does it. But let's put Boost Beast in test, and then let's compare it with the Go, and then let's see who is faster, right? So I decided in Go, it's quite simple. It's one of the very first examples that you get in Go Tour on Golang's website, so that you just do one line kind of thing, and then you have an HTTP server. And obviously, this is without any tweaking. I just go build it, and then I run it. There is a whole lot connection customization that you can do, but I haven't bothered. But there is the C++ bit which you can get that you can customize every single thing. Reference, you obviously see what's happening here. It's the function template for handling requests. This is the bit that only serves hello back there res.body. This is the example from Vinny Falco, which created this library. So I'm not making stuff up. I'm not making it slow on purpose or something like that. There is the other bit, which is also obvious with the session kind of thing that you also need to declare. You get the point, right? It's brilliant, but it's a little bit too complicated for me. And when I tested it, it was like, it was around tens of millions of requests, and then I tested it several times on other machines. But the difference were not that big, I would say. So the x-axis, I don't know if you can see it on this screen, which is flicking. This is the Apache Bench concurrency level. So it means the number of clients that the testing Apache Bench would produce. So I went from 16 to 8K. When I got lower, it started causing problems. So you can see that C++ obviously is winning. But I would say it's around maybe 5% maximum, something like that. So I would say you can definitely check it out if you want. There is a lot of successful stories with Go, and one of the biggest ones that got me to talk about it is from deal.google.com. I don't know if you know the service, or how many of you do know that use deal.google.com. That's the biggest service that goes that stands behind the downloading service at Google. So whatever you download packages, Debian packages, Chrome OS, whatever, this is behind it. And they've had this problem that around, I think it was 2010, 12 or something, you couldn't get an apt update from Google. It was really disgraceful that they were serving like 200 bytes a second. And they decided that they need to do something with it, and there's a brilliant talk by Brad Fitzpatrick about it that you can definitely go check out. And they decided to rewrite it in Go, and they had many problems that the code in C++ was really complicated, event-driven callback spaghetti and stuff, and they could have just go and fix that or rewrite it in C++, but they decided to give it a shot, and they got quite good. And as of now, they are actually serving what they started to serve. I mean, 10 years ago, but I mean, with the same fluency, and they can scale easily. More successful stories with Go, I would say Docker. You probably know Docker, Kubernetes. They have no issues using Go. At CD, there's a huge distributed key value store people use, and they have no problems. Cloudflare's distributed DNS service, that's the one that probably you use, and you don't even notice until something goes bad. There's many more. Companies, there's many of them. Google, obviously, DigitalOcean, Canonical, Heroku is one of the big ones as well. So to conclude and not bother you anymore, it's like if you next time you pick a tool for a job, consider Go. You don't have to pick it, but just consider it, and they take maybe some consideration as Google did for the service. If they did it, maybe they have more resources, but if at their scale, if they manage to use it instead of C++, maybe we can do it as well. And that's it. So if you've got any questions, I'll try to answer them. If not, No, it wasn't on purpose. I tried to squeeze it to the 45 minutes. There are no exceptions in Go. They use error as a value notion. So you get, maybe you haven't seen that, maybe I haven't shown that, the many standard or not standard functions, they return, they have like a tuple return thing, which you return several things, and one of them is quite often is an error. So you return a value, comma, an error, and then you inspect the error instead of classical exception approach.
Can you enforce that the error is checked, or can they just ignore it silently?
There is a thing you cannot enforce it as of in like a feature in the language, but the thing is that as I've shown you, if you get something from a function or you declare something, you have to use it. That's the only thing that you get. It's not the thing that you want. You would like error inspection, not that it's used,
Yeah.
right?
So if I call a function that returns and don't do anything with the return type, that's an error?
You cannot compile that code. Yeah, that's one more part, so that you can. I think I can. If we are able to put the code on there, then I can show you. I think we can enlarge it, or not, really. But basically, the idea is that that you. I'll not be showing anything because is it visible or not? No, barely. All right. So the idea is that you get the your question was about the return time, the tuple. The yeah. So what? Yes. Yeah, I know where I was going. So the thing is that you can ignore values if you decide to. So that there's a construct that you put an underscore and then you can ignore things if you're willing to. So you just get the parts from the tuple that you actually think. It's like I think it was stood ignore or stood. I don't know what it was, but you could have ignored not from the tuple but from other parts. You could have done that in C++. There was thing like I don't remember which one. But an, an error is a return value as well. It's just yeah. Yeah, you can if you deliberately want to do that, yeah, you can do it, yeah. Yeah, yeah. Yeah, yeah, well, yeah, there is like it's like close to terminate but not yet. It's like people don't use panicking. There is like a panic and recover kind of mode, but if you that's not the error checking mechanism, right? If you panic, then just kind of like terminate and then yeah, 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 yeah. That's it. Any other questions or remarks or? Then that's it. Thanks a lot that you stay here.